Nancy Kellogg. Welcome to the Why Build a Zero Energy Ready Home. Joining me today is Scott Mills with All About Saving Heat, and I'm Nancy Kellogg with the Southwest Energy Efficiency Project. Please hold your comments till use the chat bar, and we will speak with you about any questions you may have. Please hold your questions. We will answer questions at the end of the broadcast. So let's get started. The Zero Energy Ready Home program is an incredible program. You can use most residential buildings. And it's a step process, stepping into ZERH. I will use this diagram to show you how it's an easy step if you're building to building code or to the Energy Star program. You only need a low HERS from 48 to 55. The ZERH program utilizes 6 building blocks. They optimize the enclosure, water protection, optimize comfort, complete indoor air quality, efficient comps, solar energy ready. These 6 building blocks reduces risks in your building. This is one of the advantages to having being a zero energy ready home builder. You get personalized marketing materials. The enclosure, for most people, there's not an additional burden if you're building to the 2012 International Energy Conservation insulation level. Independent verification. That's your HERS rater. Missed opportunities. The HERS rater comes on site during the building process and finds defects and corrects them before they're covered up with drywall and siding. They eliminate a lot of problems before you're even close. And this picture to the right, it shows very poor insulation. It's there, but it's not installed well. The HERS rater will give a grade to that insulation and tell the builder about it. The verification areas are moisture management, the thermal enclosure, your exterior of your building, the HVAC systems, they're verified and inspected, indoor air quality measures, efficient hot water, and optimized ducts. What you're trying to avoid is missing parts of the building. This is missing the kick-out flashing. This shows what happens when you're missing that flashing. Water, it cascades down and absorbs into the building. Here's the solution. Fix make sure the step out, the flashing is correct. These are a lot of little details that the HERS rater points out and helps you with your trades and your builders. It's an incredible process. This is showing the level of detail the Department of Energy will help you with to avoid issues in the future. This is, I'm sure, I don't know if your HVAC installers have left you with this type of mess, but this does not work. You're going to have callbacks and you're going to have issues. So when you're doing HVAC quality design, heating, ventilation, air conditioning, basically you're building to the manufacturer's specs, and you have a third-party person checking those specs and making sure that it's done correctly. This is an example of the importance of ducts. I'm sure you've heard of having a more efficient furnace, but if you have an efficient furnace with inefficient ducts, then it doesn't work. It's better to have a less efficient furnace and a more efficient duct system that's tested and well sealed. You get a higher insulation, you get a higher performance level for the life of the house. Here's some examples of what you can do to avoid putting your ducts in unconditioned spaces. These are all figured out, and they're workable with most builders. And so you have an alternative. You can adapt your design easily, and all of these systems that I'm showing you right here are different ducted systems. This is a high velocity system. This is a system in the crawl space. But the basic thing is to make planned short ducts and have jump ducts to go located between your spaces. And you can have a hardship waiver, but I wanted to point out the ductless HVAC system in red. That's a great alternative. A mini split, a ductless system is a great way to go, especially if you're going for all electric. It eliminates so many problems with your structure by not having those ducts. Another very important part about the Zero Energy Ready Home program is having comprehensive indoor air quality. It's incredibly important. We look at the moisture, HVAC, the CO levels, materials, pests, and radon. Colorado and most of sweep states are in a high radon map area. We want to make sure you're protected. Also, your smoke alarms, your CO alarms, we make sure that they're tested and they're located correctly. And this is an example of isolating your garage. All the details are worked out, so the builder, with the help of your HERS rater, doesn't have to, he's not alone, and it's explained. The Building Technologies program has videos and diagrams and instruction. This is just one detail of how to make sure that you're safe and keep the exhaust gases out of your house. This is I'm sure you've all seen this. This could have been a picture taken in my house. Having ducts and using building cavities is not effective. Also, it's important that you have the proper filtration system and that you maintain it. A ventilation system that isn't maintained is like being a smoker. Not a great idea, but people still don't maintain the health of their lungs nor the health of their buildings, regardless of the risks for their health. Change your filters, set up a system where you do this on a regular basis. Another part of basically on the Zero Energy Ready Home, we are reducing the loads in your house through the envelope, through your water, and we're increasing the air quality. And once you've gotten the structure with the loads down, you have miscellaneous energy loads that take up more of your energy use. And so the Zero Energy Ready Home addresses those issues as well by installing certified E-Star, Energy Star appliances, fans, lighting. LED lighting is great, and WaterSense. This not only saves water, but it also saves energy. This is an example of a WaterSense plumbing layout. They make them in centralized spaces, so there's shorter runs, and it's also easier to maintain. Here's another example showing a system with a manifold. And the WaterSense, I'm sure you've all have waited for hot water to wash your hands. This, let me go back there to that slide. With the WaterSense specifications, the rater tests and makes sure that you the timing and the temperature is right on your, it's tested, installed correctly and tested. It's an incredible part of the program. Solar energy is basically added on after the Zero Energy Ready Home. Scott will speak more about this, but it's really gone down. But the Zero Energy Ready Home allows you to be ready for future solar when you want to install it. Our region, all of the sweep states, which are the Four Corners, Nevada, and Wyoming, are all in solar ready required, which is great. But you are not, the solar PV ready, the PV ready checklist points out, make sure that you're able to have solar, and there are also allowances for multifamily. So it's a flexible program that builders can work with, but they make sense, these suggestions. This is having the conduit ready after you've examined your orientation and ability to have solar. Then you have a dedicated area for the inverter. You have a conduit running to that inverter and the electrical panel. You have a circuit breaker for the solar in the future. And this one I really like, documentations. Your buildings are already designed for snow loads and for solar requirements. But one of the problems that homeowners have if they want to install solar in the future is they don't have the documentation telling them that their roof can handle the snow loads, and that's required before you install a solar system. So part of the Zero Energy Ready Home program is providing that documentation to the homeowner. This is a savings of like $4,000, and it's required to make sure that that homeowner has that documentation. So it's truly a plug-and-play system. The Department of Energy has already compared, done estimates on cost savings relative to codes of like 2009 and 2012 minimum code houses. And you have various mortgage advantages with the Zero Energy Ready Home program if you have an energy efficient mortgage. And the resources are available on their website. I know this isn't a pretty, there's no picture. I was going to include a picture, but this week, maybe some of you heard, we had a snow event, a blizzard in Colorado, and having energy efficient buildings is crucial to resiliency in homes. It is so important. People that live in efficient housing can stay in their houses during severe weather events and be comfortable and live. It's very important. To be a partner for the Zero Energy Ready Home program, there's no charge, first off. And so register there's an electronic agreement, there's technical guidelines galore. The Building Technologies program has a wealth of information and diagrams and resources available to the Zero Energy Ready partners. There's an electronic sign up. It only takes a few minutes to sign up for the program. And you can also choose optional commitments, such as being 100% zero energy ready home builder, or the WaterSense guidelines meet all of the guidelines. The Zero Energy Ready Home program does not require that you meet all of the guidelines, but you can choose to do that and show your commitment to the program. Fortified guideline IBHS and meets the quality management program. Let's see. Okay. Another incredible part of the program is the recognition that the Department of Energy gives you. They have designed marketing materials that are plug and play. They're very nice, such as this brochure. This this lower section on this brochure shows the Thrive logo, Thrive Home Builders. They're a home builder, 100% zero energy ready home builder that's based in Colorado. And they take full advantage of their marketing materials that the Department of Energy provides. Another nice thing about the program is this is another marketing material. It's personalized to your business and to the home. You can add pictures, and it's full of these details like recognition after sale in their home manual, Zero Energy Ready Home Manual. They remind people, they show people why their home is great, showing the building blocks for resiliency and efficiency. I would not buy a home without the thermal protection, water protection, comfort systems, efficient components, healthy home, solar ready, and enhanced quality assurance because it's been third-party tested. The most expensive thing that most people buy is their home. I would not buy a home without these protections. Not a new home. It's so nice to have all of these protections with the backing of your HERS rater, your builder, and the Department of Energy through this program. So in the process, become a builder, a partner, sign up. It'll take 5 minutes. There are no charges to sign up for the program. MEPs are mechanical, electrical, and plumbing. So we recommend that you do a design process and look at all of your systems before you build the home. Discuss it with your builder, or your builder, I'm sure, has discussed it with his electricians, his plumbers, and his mechanical HVAC people. But then the rater does a plan review, does site inspections. There are samplings for multifamily projects, or if a builder chooses, they can inspect every home. And then the rater verifies the work that's been done, submits it to the registry, and you're listed on the Zero Energy Ready documents. You can look yourself up. It's great to have national recognition. Basically, this is one of the you get certificates saying what your home is, and here is a Zero Energy Ready a HERS certificate showing the index of where your house stands. Basically, we're heading to zero, so the lower the better. Zero means you produce as much energy as you use over the course of a year. And you can also get negative numbers, so you're energy positive. The Department of Energy has this Energy Star program, and it works. It's the same process. It's very similar, only the Zero Energy Ready Home program has stepped it up. It's a much better, much more effective. They added in components that reduce your risk as a homeowner and as a builder. And so, and let me leave you with some information on become a partner, next steps. There's really no charge. And they would like you to build one home a year under the program, but many builders have signed up and are still working through the process and haven't registered very many homes, but you can still be on the registry, and interested homeowners and building officials can find your name. And that said, I thank you, and hopefully we have a few questions. I will turn it over to Scott now, and he can share his information. Here you go. I'm sorry. There was a moment on my transfer. Take it away, Scott.
Okay, can you hear me, Nancy? Are we doing okay? Do you hear me?
Yes, I can hear you.
Okay, good. So I'm going to just get started. So hi, I'm Scott Mills with About Saving Heat. We're a building optimization and retrofit company. We've done over 35,000 retrofits over the last 40 years. I've done about 1,500 retrofits. Most recently, I did 400 units of employee housing for the city of Aspen. Presently, we're starting on another 400 units for the city. My background, I'm trained in Passive House. I'm a BPI building analyst. And I first got interested in energy efficiency back in 1954 as a little kid. My father was a spec builder, and we were in Los Angeles pre air conditioning, and he took a 2x4 wall and stuffed 8 inches of insulation into it, and he threw 12 inches of insulation on bats on the attic. Basically, he had a 2015 insulation envelope in 1954, and our home, without anything other than the insulation, stayed right around 75 degrees when the average home was between 80 and 90 degrees during the summer once everything heated up. So I've been around this for quite a while. I've worked mostly in forensics, and over the years I've seen where there's a lot of problems, not by the builders, but more because of the code, because all builders will build the code. And so it's more code problems than it is builder problems. When I built my own house, I had R50 walls. And again, it was just simply more insulation and not any big systems. And I'm up here at the top of the Rockies. I'm at almost 7,000 feet. And again, I could barely get my house summer or winter off of 70 degrees. So what I'm here to talk about is how you take the Zero Energy Ready program and you can step up to the next level. This isn't future casting. This is all about what you can do now today using simplified building techniques with the Zero Energy Ready template as your starting point. And then I'm going to show you how you go beyond Zero Energy Ready to positive energy homes and how you bundle efficiency, solar, batteries, chargers, and EV into a new home, and that it actually pays for itself, gives you positive income back at the end, and you're not paying any premium. You're actually getting a 10% premium by certifying through the Zero Energy Ready Home program. So the big thing we need to understand is that when you can build a better house and you can reduce the energy, uh, uh, solar energy is free fuel. So you got to keep that in mind, and you have to understand how things change so quickly. Here we look back 100 years, and within 15 years, New York City went from all horse and buggies to all combustion engines. And even then, we've gone from taking generations and then decades, and now change is as simple as we know with like Tesla. They'll download new information into their cars from the cloud. So change is just quicker and quicker, and you need to be understanding that you need to keep up or you're going to really fall behind. And so everybody's looked at baby boomers as really the leading edge of everything, but really they're now retiring, they're empty nesters, and they're downsizing everything. And so millennials are now 60% of the new home market. And in the same way that they don't want to have to walk around with a desktop, they walk around with a phone and do 90% of their information. And they look at their homes in the same way. They're not looking for big cars, they're looking for efficient cars, and they're looking for high efficiency homes over code built. And they also want their improvements in the mortgage. The problem with the Zero Energy Ready program is if you're zero energy ready, you're ready for solar, well, most people buy to the extent that they can pay. And then if someone says, oh, by the way, you can spend another $25,000 on your home and you can put solar on it, that doesn't work for them. That means they have to refinance their home. They have to come up with money out of their pockets. And so what we want you to understand is that you've got to bundle everything into the home you're building today. So 70% of the energy in the United States is consumed by commercial, residential, buildings, and transportation. But 85% of that energy is lost from extraction and transportation, processing, um, producing the energy, and then transmitting it over the wires and into our leaky homes. Only 15% of the energy, all the gas, all the coal, all the oil, only 15% of it actually does any work for us. So we have this real obligation and potential opportunity to deal with this orchard of low-hanging fruits. And the best way to do it is through efficiency. So you see here on the left, the red bar has the cost of new energy resources. And the cost for efficiency is 0 to about 5 cents a kilowatt hour. And then over on the far right is your solar PV, which is the most expensive. So really what you find is that starting with building a good envelope through and using the Zero Energy Ready program, you can bring down the cost of solar because you're not wasting your solar energy on an inefficient house. A high performance home with proper orientation, insulation, air sealing, and good indoor air quality can reduce the energy needed to heat and cool it by 90%. So if you can reduce it by 90%, it becomes very cost effective to add solar. And investors are moving towards more and more investments in efficiency because they know it's the cheapest first cost for performance buildings. So let's see how this all works out. Here was 2 homes. One was built to the 2006 standard, and then the second one had a $20,000 upgrade in the efficiency, basically insulation, air sealing, simple things like that. And what they found out is for the cost of the energy to keep the house hot and cold during the year was $3,000. But after the investment of the $20,000, but it was put into the mortgage only costs $1,200 a year. So about $100 a year for a $20,000 upgrade. But the efficient homes saved them 75%. So they saved $2,200. The final number is that at the end of the year, they saved about $1,000 a year. Most of the accountants will say, well, that's a 20-year payback. But if you take that money and reinvest it into solar and batteries and a charger, what you find out is here you have $1,400 as your yearly mortgage on a 30-year mortgage to add your solar, your battery, your chargers. And now most of that is being paid for by the efficiency savings in the building envelope. And then when you kick in a electric vehicle, you'll see that the average, and this is if you drive a truck or if you're driving big Suburbans or things like that, it can double the cost per mile from 27 cents to 50 cents. But just as an average, it costs about 27 cents a mile based on 5,000 miles a year most people drive. But if you put it into solar and you're paying for an EV vehicle, you're only paying 4 cents a mile. So here you see again, you've got another $1,000 you just saved by incorporating all the modern features that a millennial is looking for. So if you're building a house and say it's got the solar, the charger, the batteries, everything's ready to go, you just got to plug your new car in. This is what they're looking for. So you've already paid for this. So a millennial looks at this and he'll say, okay, I can either buy lots of oil and coal to run my home, or I can invest this into solar panels and things like that and run an electric vehicle. So who's going to say no to a $50,000 upgrade that pays back every year? You get a 97% return on the investment, which is more than you're going to get from countertops and bathrooms, and a 10% resale premium. And it's going to give you a lot more than any granite countertops or any other wood floors that you know you're going to have to do to make buyers happy. You can't go with Formica and vinyl and things like that anymore. And now efficiency, solar, chargers are now on the table for what people want. So now we have our building codes. And I think I missed so anyways, let's go with the building codes. So as a retrofitter, our number one problem that we run into from home buyers or home owners is comfort is number one. Number two is high utility bills. And it's not about the builder. We're not here beating up the builder. We're beating up the codes because they don't require proper air sealing. They don't require exterior insulation until most recently. And so the cost to retrofit a home it could be $50,000, it could be more depending on the house, but it's always first cost in a new build is going to be cheaper than going back. Just look at it as if you went and found an old 1960s car and you wanted to turn it into a brand new car. It could cost you $50,000, $60,000, where you can go out right now and buy a brand new car for $25,000. Same kind of idea. So you just need to understand that in the end, our building codes are going to be zero energy by 2030. And these codes are going to change every 3 years. So you can accept the Zero Energy Ready program right now, and you'll never need to go through code changes ever again. So our problem in my valley, in the Roaring Fork Valley, we have 3 county overlay, have about 6 municipalities. Every single one of them has their own building departments. And even though they're all on the 2015 code, you can go to Aspen and they say you don't need a blower door, but you do need one in Snowmass, and they want a HERS rating. But if you go to Carbondale, they don't have a HERS rating, but they want to have an encapsulated crawl space. So even though everybody's on 2015, they are still different because of home rule. Every municipality, because of home rule, can make their own choices of what of the 2015 code or 2018 code they want to use. So in the end, when we get to zero energy ready, it's going to look like what we've got right here. As you saw, it's all pretty simple stuff, what Nancy talked about. And so here's what it looks like. So if you look down here on the right, here's the 2015 IEC HERS rating. And then the next one down is basically your zero energy rating. So there's very, very little difference between the two. So why do we want to go ahead and do this? Why don't we just stick with the 2015? Well, the thing is any kind of certification, homeowners or home buyers are willing to pay a 10% premium. Door to door, next door neighbors, if one certifies and one's not, home buyers are paying that 10% premium because they know they're buying a better building. It's certified. And this is so this is what new home buyers want to know. And as a builder, you have a simplified checklist so you can build these homes. And with the marketing brochures, here's Thrive once again. And when builders and real estate, or not builders, but when real estate people are driving around with potential new home buyers and they see a zero energy ready sign on the outside, they want to go in and see what's going on. You'll have badging that's going to show them what's going on in the house, and you're going to have brochures on the inside that's going to show you and the buyer in dollars and cents how you're better than the competition. And this is going to make you, as a builder, become part of the top 1% in the country. And this is a huge thing when people are saying, well, which house do I want? And you've got this choice or the other guy. Well, most people are going to say, I support the Department of Energy. I understand it's certified, and these guys are really what I want to work with. So they give you everything you need to know with the answer to every question. So as a builder, you go to the Building Solution Center and you can get all this different information, CAD galleries. They're going to give you checklists and really walk you through the whole process. So going into positive energy, you need to reduce your energy footprint. And so if you remember just these 4 basic principles and keep a focus on them through every stage of your building, you're going to be quite easily be able to fulfill the zero energy ready criteria, because this is the stuff that really carries it. So with orientation, how does that work? Well, if we're way out here in the middle of nowhere and 500 degrees below zero, how is it that we have such a nice world to live in? And it's exactly what we're talking about. And we've known about this for a long, long time. And we've known how to use the winter sun and the summer sun to stay comfortable and use shading. 6,000 years ago, China had building inspectors, and before you could build, you had to show them where the solar orientation was going. And they had basic design criteria that you would have to use, whether it's a little small home all the way up to their palaces. Rectilinear homes facing the sun, separated from each other enough so everybody gets sun. Even when they laid out their towns, everybody had to lay out their buildings to make sure that they receive free solar fuel from the sun. The Greeks did the same thing. Here's a Greek house from 3,000 years ago. Looks like a modern passive solar apartment building. But they did something a little different. They kicked their houses out a little to the southeast. And the reason being, as you can see here, the southeast first sun is warming your home. When you're due south, you may not get any real full sun until 10, 11 o'clock in the morning. So when you get up in the morning, you're still heating the house. When you get home at night, you're still heating the house. But this sets you up, and with a good envelope, it'll carry you through the whole day. So here's a house where they put the corner of the house facing south. Here's the southeast, so the morning sun flooded in, southwest, afternoon sun flooded in, good eaves over the top for summer cooling. And most people say, well, that's too much glazing, but we can handle glazing now with our low E coatings, and we can pick and choose how much heat we want to let in and out of our houses. So what are we doing with our homes? Are we doing anything similar to that? Well, not really. The only good solar orientation we have is summer sun on our rooftops. So what we started with is in the oil crisis, nobody looked back and really tried to look at history. They just tried to reinvent the wheel. And we made a lot of missteps and a lot of crazy ideas. But what we found out was that using basic principles of thermodynamics, we can do this. Now, this is a zero energy ready home from Durango. And they use about, what is it, about $1 a day or so to keep their house warm year round. And they had a rating of 21. They have the solar panels over here. So they pretty much close to zeroed out their house. You know, $400 a year is an extremely high price. And here you can see Passive House, which is a very, very technical way of building. It was done for $200. Here's Habitat for Humanity. They get a lot of free insulation and things, but you can do it for $100 a square foot. And what you want to remember is free heat and free fuel from the sun based on your orientation. Next thing we look at is air sealing. We lose 40% of the heat just because of air leaks. I work with people a lot of times, and they're all, bundled up in their house, and I'm visiting them to talk about what they need to do to their house. And really what they're spending their money on are ice dams on the outside, and they have to turn down the heat on the inside because they can't afford it. So again, we've got the details. So you can go in, and these details can be on a tablet or even on your phone. You can go out, talk to your subcontractors and other people that you're working with and show them exactly how you want it, and you can check and make sure they're doing it right. The big takeaway on air sealing is you want to do it at the rough end, not at the end of the project when you're trying to get your certificate of occupancy. When the walls are open and there's no insulation or drywall up, you do a blower door. It's really easy to find these houses or these leaks in these houses, and you can reduce your leaks substantially without too much work. But here's my friend Floyd. First time around, he goes, well, this is kind of, hell on wheels for me, because wherever he looked, it was just endless, where he was chasing down air leaks everywhere. But really, you can bring in subcontractors. Our company does this type of work, and we can do a house all the way from the crawl space through the attics in about a day, and it costs maybe $1,000, $2,000, and you can get it to really low levels of infiltration. And just think of a thermos. You've got a coffee cup with the lid off, or you've got a sealed up thermos. Thermos will stay warm for hours. The coffee cup in a few minutes is cold. So here's where you find all your leaks. Biggest leaks, crawl spaces, attic, top plate. So this is what you want to look like. You want to chase all these leaks down. If you have can lights like this, you want to change them out to sealed LED lights like that. They have gaskets on it, so you actually seal all those little chimneys going up into the ceiling lights. Then you want to make sure your roof is baffled right. This is usually what we see, real cheap plastic, and we'll go in there and blow insulation, and the baffles actually blow away. Excuse me. But we like to use cardboard baffles. You can get a dam so your soffit vents don't get filled up. And so this way you can get a lot of air in there, reduce your damming, cool your attic, which in turn is going to keep your house cooler during the summer. Then you got to look at underneath the house. We want to make sure that there's no thermal bridging. And here's a way to pay for all this work. So I did this on my own home. My contractor, the concrete contractor, said by doing this frost protected shallow foundation, I saved $30,000 from a standard footing that had to be extended below frost line. And basically, that's the foundation here is 2 feet. So you go down 2 feet and insulate that, and then you go out 2 feet is equal to a 4-foot foundation, and that's all that concrete is now taken out. And for $30,000, you can pay for a lot of insulation, air sealing, and some nice windows and doors. You know, so you get your details, so you know exactly how you want to do it. And this is the beauty of the Zero Energy Ready. It really carries you through it. And if you don't want to do it, you just go ahead. There's a lot of simple ways to bring some stuff in and have it done real quick and easy. But again, here's your crawl space. And this is what you want to make sure of, is that the rim joist is caulked, your penetrations are caulked, your mud sill is caulked. We like to throw in an R19 bat. So now the rim joist is nicely insulated. All your penetrations in the floor you want to seal up. And this is the beauty shot of my presentation. I call it my centerfold. This is your unvented, semi-conditioned crawl space. You've got your vapor barrier. It's all glued and attached to the walls. You have an R19 bat. It's a large 4-foot long bat we roll out, and it has radiant barrier on it. Now we put that up against the subfloor. Now you've got an R38 rim joist, R19 on your foundation wall. 97% of the heat that bounces off this radiant foil goes back into the floors. We don't even insulate the floors, and people find it's like radiant heat because you don't have all the evaporative cooling from the cold, moist air coming up through the ground. So this is what happens when you don't do anything right, and we can come in there 20, 30, 40, 50 years later, and everything's pretty much gone to crap. And it just becomes really a nightmare trying to fix this stuff. And we're up in what's called an alpine desert in our area, and we're running into more and more mold because of better air sealing, and then all this moisture from the crawl space is being trapped inside the walls, and it turns into pretty much a big problem. So anyways, we're going to get it all buttoned up, and now we go into insulation. I really have a problem with foam insulation, and it's not just me, it's the EPA, because the potential for off-gassing of volatile chemicals from spray polyurethane foam is not fully understood, and more research is needed. So even though probably 95% plus of all insulation in high-performance building is either a foam board or a spray foam or a flashing bat, you got to keep away from that, because even though they'll tell you that the spray foam is safe, because it's a 2-part foam, it could be, depending on humidity, depending on the temperature, there's a lot of problems you can have if it isn't absolutely perfect. And now they've added fire retardants to the foam, and that's where the really bad outgassing is. And then again, if there's any water leaks or anything that are coming down through the building, they're all hidden until things rot out. And from my experience, the biggest mold problems that I run into are based on interior spray foam on buildings. So here's your other choices: cellulose, fiberglass bats, and then the top left is my favorite, rock wool, which we'll get into in just a little bit. So the big thing that we got was the 2015 is added continuous. It's still on the 2018. Insulation, the most important thing you need to understand is exterior insulation. You don't get points on a HERS score, and nobody's going to say that it is, but BPI and the 2015 IECC says that exterior insulation will eliminate thermal bridging, doubles the value of the insulation on the inside. So the real sweet spot is going to an R50. And so I'm going to show you how you can get to an R50 with a 2x6 wall with exterior insulation. And this is what no thermal bridging looks like compared to the neighbors. And that's why I say when you do a certified house, Zero Energy Ready, compared to the neighbors, this is what the difference of what they're getting. So most people always say, well, we're going to go with the double stud wall and all that, but it's really, for a builder, it's way, way, way too expensive. And every layer that you add is just another opportunity for moisture to get between components, mold can start going and things like that. So what we want to do is the perfect wall. And so here you have your basic 2x6 wall. Over here is your interior. And then you've added your exterior wall. You have your control layer here. And it's pretty simple. So let's say we have an R10 exterior, R19. We've doubled the value to an R38. And add the R10, so you're at R48. So basically, you're getting that R50. Again, you're not going to get this on a HERS score, but as a high performance building component, you've now eliminated the exterior thermal bridging, and this interior suddenly becomes mass and it holds all the warmth. So this is really the big deal. But you got to remember that all these components and layers have to be connected. However you lay out the house, you've got to be able to run your red pin around and make sure everything's connected. And so here you see how you have to connect. Here's air barriers that were left out between a garage and a house. And this is what you have to do to make sure it's right. Again, people had a front porch that was an enclosed front porch, but it was left open to the interior subfloor. And there's another huge problem where cold air is getting into it. So rather than going through a lot of different surfaces, you now have this system. It's the ZIP system. It is vapor open, water closed, air closed, and it's really pretty simple to put up. It's a lot simpler than dealing with house wrap. And this moves us on to rock wool. So rock wool is basically use steel slag. It's fireproof to 2,000 degrees, and it's hydrophobic, meaning it doesn't soak up water. There's a fire test done on foam walls, fiberglass walls, cellulose walls, and rock wool walls. The foam and fiberglass went up pretty much immediately. Cellulose was a little bit slower, and the rock wool has a 90-minute fire safety rating. So using this both on the outside and the inside, you really have a wonderful fireproof building, and it's hydrophobic. So if any water gets inside here, it's going to roll down. If it's in the roof, it's going to show the leaks. If you have foam, it's going to hide it. Things are going to go to dry rot or mold. If it's fiberglass or cellulose, it's going to fill up like a sponge and then explode. So this has some really good components to it. Price and R value is right in the middle between fiberglass and foam, so it's really cost effective. So here you can see how you could put a couple of inches, which is about an R8, on a 24-inch 2x6 wall. And we go out here, and it's about what they call effective value is 27. So if you have 2 inches on the outside, you have an R27 on the end, you're already over an R50. So you could literally use a 2x4 wall, come down here, put this on the outside, you're already up to about an R50. It's really easy to put in. Guys aren't running around in hazmat suits. It's easy to do cuts around plugs and switch plates. They use butter or bread knives on it. You can see you don't need to staple, spray, or anything. They're made a little bit bigger than the width, even up on ceilings. They can go right in really quite easily, and you can use it wherever you want in the house. So now it isn't foam board underneath the foundation or foundation walls, spray foam on the interior, cellulose in the attic, all these different things. You can use rock wool throughout the house. Final thing we are going to look at is ventilation, because when we get super air tight, we've got to bring in fresh air. And this is the big deal that you really gain from the Zero Energy Ready program. And so what we've seen in the past is this is just a standard Zinder ERV, and it doesn't have any heating, so you still have to run full furnace ducts, and you've got all these home runs going all over the house. It's really crazy. In Canada, they found a way to put heating and cooling with it, but it's still the same basic product. If you're still using a forced air furnace, you can add air intakes. This is a standard commercial fresh air intake. It's really easy to add to your furnace. But is this really where we're going? Do we want to just keep adding on, and having more and more problems? And don't forget the duct blast. If you get in an area that you have 2018 with the duct blast, I know people that it can be tens of thousands of dollars to get that sealed up. So really, where I recommend people to go to is to radiant heat. It's my favorite go-to. A lot of people talk about mini splits, but by the time you get your mini splits all over the house and all the different rooms, it's the same price as laying in radiant throughout a house. And radiant doesn't have any dust or germs or anything like that, filters that have to be cleaned. You're just warming the floor. You just have to make sure you do the details right. I run into this all the time where the guys just nail it up, but it's hanging, and people wonder why they don't have their floors aren't warm, because all the heat is going out through the vented crawl space. But doing some simple things, here's a few $100s extra to do on a floor, 60% improvement. And then you can use something as simple as this. This is a Panasonic ERV, and this will do about 1,000 feet. It's about a 3-foot by 2-foot bathroom fan, so to speak. And you can put it in a hallway or in a kind of a midway in a room, and it will terminate right to the exterior. So you can run it right between the floor joists, and you can bring in fresh air and into a house, and it's really cost effective. It's probably around $1,500 installed, and it'll cover about 1,000 to 1,200 square feet. So for $3,000, you can take care of a 2,000 square foot 2-story and get all that fresh air in there. So just remember with the Zero Energy Ready, it sets you up to get your envelope ready. That's going to save you on the expense of the solar, because when you get a HERS rating, you take that HERS rating over to the your solar people, and they'll take those numbers off of that, and that's how they design it. And they're going to give you all the checklists that you need to become one of the top 1% builders in the nation. So thanks so much for taking the time. I hope everybody enjoyed it, and thank you, Nancy.
You're welcome. Thank you, Scott. And just a reminder, the Zero Energy Ready Home program is very flexible to work with your designs and trade-offs. Whatever you need, they can work with you in the Building Solutions Center to work out any issues or questions you may have.
Right, exactly. So if someone has a really strung out 1-story ranch house, and you can't get your numbers right on the length of the runs of your plumbing, you can trade out and have a little more insulation in the attic or a little bit higher performing heating or cooling system, and that will still get you into the numbers.
Right. And so if anyone has any questions, please raise a hand and we will try to answer them. If not, I have just put up my email and the email for the Zero Energy Ready Home program. Feel free to check us out and write me a message. We would be very happy to speak with you. I hope you enjoyed today's presentation. And oh, I think I see a question. Let me see what I can see. I'm looking over to see if I have any questions. Okay, we are coming to the end of this webinar. We are having another webinar next week at 2 p.m. Mountain Standard Time. Thank you very much for helping me today, Scott. Next week, we'll have the voice of a builder. Thrive Home Builders will be helping me with the presentation. And but I appreciate Scott for joining me today and giving the view of a retrofit builder up in the mountains of Colorado. Hope everyone is fine and has a great St. Patrick's Day. Take care, and I will please contact me with any and all questions or answers. Take care. Bye.